since we already know that there are different types of definitions of the probability, that's classical, the one based upon the relative frequency, and the subjective probability. Then there's another definition that's called axiomatic definition of the probability. In this module, we will be talking about these axiomatic definition of the probability. In 1933, the axiomatic approach was given by a Russian mathematician, A.N. Kolmogorov. The basis of this approach is embodied in three properties from which a whole system of probability theory is constructed. And he used mathematical logic to construct these three elementary properties. The first property, or the first axiom, is called the axiom of non-negativity of the probability. Then the second axiom, or the second property, is the axiom of exhaustiveness. Third one is the axiom of additiveness. Axiom of non-negativity says that the probability is always non-negative. So given some process or an experiment with n mutually exclusive outcomes, E1, E2, up till En, the probability of an event Ei, which is any event out of these all n events, is assigned a non-negative number. That is, probability of Ei is greater than or equals to 0. Therefore, we can say that all the events must have probability greater than or equals to 0. A key concept in the statement of this property is the concept of mutually exclusive outcomes. But this is also true that all the probabilities are always positive. They could be minimum, they could be 0, or maximum, they could be 1. The other axiom is axiom of exhaustiveness. The axiom of exhaustiveness states that the sum of the mutually exclusive events is equals to 1. Actually, it's the sum of the probabilities of all the mutually exclusive events is equals to 1. So if we have E1, E2 up to En mutually exclusive events, then their probabilities, when they're added, the result should be equals to 1. This property refers to the fact that the observer of the probabilistic process must allow for all possible events. If we look at this diagram where we have this big rectangular block represents our sample space, and this sample space is partitioned into 4 mutually exclusive events, A1, A2, A3, and A4. These mutually exclusive events, if we add the probabilities of all these mutually exclusive events, this should be equals to 1. Again, the property requires the events to be mutually exclusive. The third one is the axiom of additiveness. The axiom of additiveness states that for any two mutually exclusive events, let's say Ei and Ej, the probability for the occurrence of either Ei or Ej is equal to the sum of their individual probabilities, which is represented by union of the two events. So probability of Ei or the occurrence of Ej equals to the addition of their individual probabilities. Since the two events are not mutually exclusive, that is, suppose they could occur at the same time, in attempting to compute the probability of either Ei or Ej, in the case of not mutually exclusive event, it would be very complicated. 3 axioms of probability help us to understand that probability of any event can never be negative, and it can never be more than 1. Hence, we can say that the probability of any event ranges from 0 to 1. Thank you.